Welcome to our conference, Creative Approaches to Sustainable Building. Thank you for taking the time out of your busy schedules today and join us here at our first online conference. We have an exciting speaker lineup with experts from Ireland and Austria. And above all, I encourage you to take advantage of the networking opportunities and schedule some meetings with our exhibitors during the afternoon. My name is Joseph Dremmel. I'm the Austrian Commercial Councillor, and me and my team, we are working here to further the relationship between our two countries. Today, our conference, we see huge possibilities in the collaboration between Austria and Ireland, and I hope that this online conference may help to deepen Austrian-Irish relationships in the sustainability sector. Surprisingly, only last year, the exchange in trade between our two countries, small countries, was close to 4 billion euros, which is quite significant if you think of this. In a moment, I will introduce Ciarán O'Connor to give the opening address. Keynotes are about 20 minutes each and will bring us right up to 12 o'clock. After that, grab a bite to eat or a coffee, but don't forget to take a moment to connect with our exhibitors and arrange one-on-one B2B meetings. Some of our exhibitors already work with Irish partners here. So in the meeting place, you might see a very Austrian name with an Irish flag, or an Irish name with an Austrian name with an Irish flag. So just don't get confused. The companies just signed up according to which company they're working for. So please book the meetings and get into networking today. If you need any technical assistance or for some reason you cannot access the B2B sessions, please message us in the chat and my colleague Connor will come back to you. Finally, thanks to my team, Dagmar, Harald, and Connor, who really made everything possible today. They put everything together. And it's, as I mentioned before, it's our first conference in this area and our first online conference, certainly. And I think so far the outturn really showed that there's interest in the area, and I'm looking forward to today's speakers. So without further ado, let me introduce today's first speaker, Ciarán O'Connor, President of the Royal Institute of Architects Ireland and State Architect at the Office of Public Works. Ciarán, the floor is yours.
Thank you, Joseph, good morning to everyone listening in, and guten Tag to Österreich. I won't try any more German than that until the very end. I had worked in Germany, which I know is very different to Austria, and it's a bit like the relationship between Ireland and Britain. You have a big brother and a small brother, and so I know what the differences are. So without further ado, I'd like to take you through a wide-ranging set of aspects that I would cover as President of the Institute of Architects and as State Architect. Previously, I had worked abroad in Germany, Scandinavia, and Canada, and then I came back to work in Ireland, and I have run a practice which was unusual within the Office of Public Works, which are many different architects, as well as played the role of state architect as defined by government policy and architecture. And we actually had a very good meeting in Vienna 2 years ago on that policy, and we're coordinating with the rest of Europe. So I'm going to just go through quickly a number of items. So I always say about the green issues, it's not for what it is, but what else it is. And, you know, I always think of that in Sevilla, where you have beside the cathedral, which was the old mosque, the drainage system for the town comes down and feeds the orange trees in the enclosed cloister. And it's the use of that water that was being used throughout the rest of the town or city to feed the orange trees, because Sevilla is too dry in the summer months for the oranges to ripen naturally. So we had 1500 years ago people who thought about that and solved it. And in the same way, we can solve things ourselves today. And so what is it? It's urgent, it's local. It also has social, economic and qualitative elements. But I believe that you have to keep it simple, but not simplistic. And there is a big difference between that. And the key relationship is between us and our world, and in a way that's as cohesive and reflective as possible. So I often think, like in situations like, what are the threats and opportunities? And not everything that people say is green is automatically good. So you have an orthodoxy or a dialogue. Do you have the doomsday versus the economic progress? These are not opposites. Or you have what some people would say woolly jumpers and green technology, or thinking against real R&D, or eco-bling, or citation rather than synthesis, or image rather than essence, or fascination with minutiae rather than imagination. And I think it's important to move past that. And this is a drawing I did many, many years ago, but I think it's appropriate, and I use it against myself as well. So this is the bureaucrat who goes to meet the Lord on Judgment Day, and he tells St. Peter at the gate, he didn't do anything, so how could he have done anything wrong, and therefore he should be let in. So I think really what the counter to that is an imaginative and critical approach, and that is European-wide. But to imagine a world without Amsterdam or Venice, yet 21st century environmental statements would say no, because they're built in a floodplain or in an estuary. So yet they have inspired us for 10 centuries. So I think we have to have a more nuance that needs to capture the elusive as well as the apparent. And it's not a simple black and white situation. Now, I'm not going to run through all of that slide, but all the environmental elements, and in our office, we integrate and we link in on many government actions, and they're all listed there, what they are. But most of the people today know what those elements are, and the question is what to do about it. So within the Institute of Architects, we have a sustainability for the crisis, which we did in 2019, and we're have our membership working towards that, and we work with government on that as well. So the advantage it has, I suppose, at the moment is that with me wearing two hats, one is government and one as the Institute of Architects, that has been a positive synthesis of two things. And just on our experience within our office here, in 1996, we did a book with the European Commission on green design. So that's a long time ago. And we've been updating our work and our approaches since then. And the Institute of Architects and the OPW were committed to sustainable design, and in the design, construction and operation, minimum impact, all the things that people accept are good, healthy, comfortable, well-being. And then it's just, what is it? It is an optimal balance between cost, environment, society, and human benefit. And that is what we have to get, is that balance, and how do we manage it? And what we do in our office here, our practice, we have a green audit plan, and we've had it for about 10 years now. And we go through that at every stage of a project. And we look at how we're conforming and what we're doing and what we could do better. And that's done under the ISO system at every stage. And I sit in on each of those reviews personally. And then our other sort of, we did the Irish Expo building in Milan in 2016, and it was deemed to be the most environmentally friendly building, and won the award within the whole Expo as the most sustainable building. And for a small little country to do that on a very small budget was some achievement. So the principles, you all know the principles of the thing of fairness and competition, environment, and how to reduce the impact, all of those stuff, the life cycle analysis, life cycle costing, all of those are still in development, and we need to keep that working. And particularly the big item, and you'd be very wary of it in Austria, as we are now in Ireland, embodied and operational carbon are two key elements to this story. And that elements of sustainability, that the lower small diagram was what maybe it was before, but perhaps we now need to adjust those circles that take in the interaction between an economic environment and social issues in a holistic and sustainable way. And we also have to meet the requirements, and we help the government in Ireland here advising the Department of Environment and Housing on new forms of building regulation. And so we are part of a group that advises them as well. At SEAI Ireland would do that also. So we make those contributions, and we're now working to near zero. And we were doing it for the last 2 years. And since last year, all buildings in Ireland have to be done to near zero. And then the application to construction all the way from product stage through to end stage. Now, some of this is in early stage of development, but we are making good progress. And within the year, we would be producing a document called Green Public Procurement for Construction in association between the OPW and the RIAI. And then the whole aspect of procurement is a big issue, and EU procedures sometimes aren't the easiest things to manage. And how do you manage that aspect from design through aspects of the circular economy to material passport and all of those elements that are needed. And the procurement is how and what are we? And the life cycle assessment of that and the cumulative environmental impact of all the materials. So we ask for the certificate of embodied carbon for every material that we use. And then we are also always looking for innovation as well, and elements dealing with departments like the forestry people and others. We're involved in developing elements of that as well. And those impacts, a lot of people would be familiar with that, the materials, the transport, the maintenance, and some of that still has to have more scientific work done to it, but it is making improvement all the time. And in that diagram on the right-hand side, all the different components that go in and how you evaluate that. And we're looking and developing that as part of our documentation. And then the stage guidance, our stage guidance that will be coming out with the new publication will move all the way from site selection to end of life and potential end use, and the steps in between. So design, facility management, and then reuse. So core and comprehensive elements, the aspect of what's minimum to do and what would be better to do as comprehensive. And we still have lots to overcome in Ireland on that with regard that if something is seen to be positive and extra, we should be able to support that. But financially, our own Department of Finance needs a bit of persuasion on that matter, as probably most departments of finance do. We're lucky in the OPW that we're part of the Ministry of Finance, so we do have a reasonable voice there to make our voices heard. And then the planning green public procurement, the roles that we'll be covering in that guidance will be those 9 different items as set out there. So it will set out the legal, the role that this office will be playing, who our partners will be, the targeting zero carbon, looking at the life cycle and best practice, site and ecology, design, and that. I should mention I'm both an architect and landscape architect, so that's one of the reasons I think the whole aspect of site design is very important. And under our new development plan for 2018 to 2027, that's now under review, and a new enlarged plan will be developed in June of this year. Our office have been given charge of certain elements of that. But these 2 projects that I just going to show you here is one is a backstreet development where there's part restoration and a new building on what was previously a car park. And the building below is the National Forensic Laboratory, which normally those buildings are huge energy users. But we have developed techniques whereby 94% of the energy will be recycled. And I don't have the time to go into the detail of that, but that has been a significant achievement for a national forensic laboratory. I don't think any of the other European forensic laboratories would be able to match that. And just to explain that as an example, this is a campus that we've been working on for over 20 years. And the forensic laboratory is on the building on the extreme right-hand side. There's a data center to go in. There's other laboratories and other special areas. But this was an area that had flooding problems and all sorts of other issues. And we went about it in a way to get rid of those problems, but to do it in a way that was sensitive to the landscape and to the users going to work there. And so we didn't take any soil away from the site. We kept everything on the site. We planted thousands of trees. We made the flooding into self-cleaning ponds, and by planting the ponds with particular species of plant, and it's now environmentally rich and biodiverse. And that project was started back in 2000. So we've been monitoring it for 20 years now. And all that knowledge will be distilled into the publication that we'll be bringing, as well as other knowledges that we have. And so you can see here, we would look at how the carbon emissions would be looked at and what levels of saving can be done. And we have then executed that in a way that's everybody can check and see in a very open and transparent way. And the cost of the thing, like how we got agreement on the financial side, was we actually worked out what the costing was of the soil. And for the total site, it's a huge site, it's 50 hectares. It was over 4 million to do all of that, but there was a saving of 3.5 million to the taxpayer by going about it this way in other savings, quite aside from all the positive ecological elements. So we were able to make both of those arguments, and I think that's important. You have to have the economic argument as well as the social and environmental. And then the element of flood control was done through attenuation ponds that have been built in as part of the whole landscape design. And again, we've been monitoring how that has worked. And the planting schemes are designed in such a way to be successive, so that you get the natural succession process that you get in nature. And I have to acknowledge, my good wife is Dutch, and the Dutch, I did a lot of study in Holland as well, and I'm aware of the great work they had done on landscape works in reclaiming of polders, etc., and in other studies. And I adapted some of their scientific studies to an Irish context using Irish species of trees and plants. And again, we'll be publishing the result of that, what worked and what didn't work. And then the aspect of that element was for people as well as for the job to be done. And the whole landscaping and the percent for art were all included in the design. So we said that these things didn't have to be just everyone in a white coat. These were also pleasant places to work. Then another project where we're doing a deep retrofit, and that is just going to go to tender now in the next 2 weeks, which is a building, a 1960s, late 60s, early 70s building, which some people don't particularly like, but I do think is part of our heritage as well. And it's in a historic setting, in a former army fort, and we are doing a deep retrofit, and it's for the Ministry of Climate Change. So everything to do with the building will be monitored and published, and therefore help people how to process it as an exemplar of how you go about doing the projects in such a way as to make them understandable and usable and energy efficient. So it would include all the things like lighting, a new lining of the building, but also maintaining the original architectural features from the 1960s, early 70s as part of that, because part of our job too is to acknowledge that. So all those elements have been done. We've agreed it with the client, who is, as I said, the Department of Climate Change. So it's very important that it is an exemplar. And so that goes to tender in 2 weeks' time. So we would hope to be on site later this summer. And it's about a 2-year project. And all of that information will be made available to different people on the different elements involved. And with regard to refurbishment, we also in our office look after historic buildings. We would have about 1,700 national monuments and historic buildings. And so we've been looking at a strategy for refurbishment of them that also acknowledges their historical architectural elements, and then where energy saving can be done as part of that, but not just to do with the buildings themselves, but to do with how we run the visitor facilities there, and what energy and design site ecology we use, and what materials we use in that, and what alterations to building services we do to bring those buildings up to the highest standard we can, commiserate with their importance as a historical architectural item. And I know you have similar issues in Austria, that aspect of how invasive you are on the historic building. So that's a very quick run through, because I'm conscious of that you need to stick to time. And so vielen Dank für Ihre Interesse und Ihre Aufmerksamkeit. I'm happy to answer questions or whatever that process you wish to do, or if people wish to contact me, it's very easy to contact me. It's Ciarán, which is CIARAN, .O'Connor without an apostrophe at opw.ie, or president@rai.ie. So I'll hand back to you, Joseph, and thank you very much.
Thank you, Karin. Excellent presentation. I really enjoyed it. And I think it feeds also perfectly into our first presenter today, whose solutions and whose licensing system also addresses this life cycle assessment of buildings in a new way, in many ways. So thank you very much for taking the time. And unfortunately, we don't have time for questions and answers today, as we really try to pack in as much information as possible into this morning. Thank you, Karin. Our next speaker is an expert on timber hybrid systems that utilize prefabricated components in large-scale projects. He is CTO and Managing Director of Cree Buildings. Welcome, Rainer Strauch. The floor is yours. Please go ahead and share your screen.
Yeah, I'm going to do so. I hope you can hear me all well. I think so. I just wanted to say hello from Austria. And I'm going to turn off my camera then again because of some bandwidth concerns. So I just wanted to show me quickly. So I'm going to turn off my camera and share my screen then. So I guess what you see is all black now. Is that correct? Yes. Okay. So let's start. So I'm managing director of Cree, an Austrian-based company, belongs to the family-owned Rabmer group of companies, and I would like to make you familiar with what Cree does here today. So now I need to change. Now it works. Looking good. Yeah, thank you for having me, or let's say give me the opportunity to present here. What I would like to show you is the idea that Cree came up with, and this is a bit of the agenda here. First, I would like to introduce Cree, who we are, what we do. Then I would like to introduce the system that we build on, make you familiar with some of the qualities that the system provides, show you the partner network, which is very important to us. And finally, the most exciting thing, I guess, is the projects we have already done. So to give you a bit of an insight, the great things that have already happened. And if time allows for, I would also mention the platform in the end that we are working on right now and what this is about. So Cree is basically consultancy company and a technology company that operates worldwide. We are based in Austria and license our IP and help construction companies and developers to build buildings like the one that you see here in the picture, which is the Lifecycle Tower 1. That was our first project in 2012. I'm right now in the building here because we also have our offices here. It's a timber-based prefabricated hybrid building It's doubled the height than it was allowed for at the time of the erection. So we really stretch the boundaries and go beyond what is common sense in the current state. I will get back to that project briefly later. So here's what we rely on and what we came up first. So we thought, how can we bring timber into large volume and tall buildings? So we thought about a construction system, a structural system, and a shell, so an envelope of a building that can be prefabricated to the most extent, and that can be very quickly erected on site. So first of all, we started with the grid lines. So we knew that we need to achieve a high level of repetitiveness, that we can also come to a good economics, right? If you do something in a serial production, you're much better off in economic ways. So then we rely on standard glulam columns. This glue laminated timber is a standard product that exists since almost 200 years now. It's like engineered wood, as we call it, that has very good properties for construction. Those columns come together with the exterior walls. Those exterior walls that you see here are non-load bearing, and they are assembled together with the columns. Then we have introduced some interior grid extension lines. Those are pretty much girders that allow us to have wider spans, to cover greater areas, to extend the building footprint. And finally, the most important thing are the timber concrete hybrid panels. So this is a mix of timber beams like glulam beams and the concrete portion that we also use for heating and cooling. So we combine a bit the structure and also the building services in this panel. When we talk about a system, we of course do not only mean the structural system and the shell, but basically the entire building. Because what we learned is if you only focus on the material and replace wood or replace concrete or steel by wood, you will never meet the economic needs of the client, right? So what we learned is that we need to look at the entire building from a holistic point of view to make ends meet in financial terms. We also optimize the process of construction. What you see here is pretty much the conventional process where everything goes linear. You have a lot of feedback loops, you lose a lot of information, you consume people, you consume resources, you consume time and money. And we think that needs to be done in a different way, where everything gets integrated right in the beginning in this Cree sense of doing things. And then the building is pretty much already there in the beginning as a digital twin. You put it to manufacturing and to assembly, and then you have a much higher quality in a quicker period of time. So this is what is in for our licensed partners, right? The construction companies, they benefit from the prefabricated hybrid components, from reduction of complexity, from minimized consequential costs from deficiency, because if you have a lot of well thought through details, nothing can go wrong on the construction site. Then nowadays, it's very important, even more important than earlier, that you have high safety standard and hygiene on the construction site. And if you only need a couple of workers instead of all these lots of people on a conventional construction site, then you have a much better control on that. So the superstructure allows for flexible layouts and easy occupancy customization. This is very important for developers. The entire concept relies on local resources. And I'm not only talking about material resources, but also IP resources. That means local designers, local developers develop the building, design the building, local manufacturers manufacture the building, and local companies assemble the building. We are not so much talking about construction anymore. It's more an assembly line. But all that is always being sourced locally. And going back to the carbon issue, that is one of the most important things nowadays. Of course, we store carbon in the construction. We improve gray energy throughout the entire process, and our core and shell stores more carbon that the building releases, which is very, very important. So that's why we call it carbon negative. There's some other quality concerns that is more related to the user, which is of course in the center of every building development. Those buildings just have a healthy, hygienic, and performance-enhancing indoor environment. What I mean with performance-enhancing, I'm going to explain later on. It's about improved air quality that also comes because of the wood, but also because of the holistic approach on the building. So the building I'm sitting in here is a DGNB Platinum building, a LEED Platinum building, and also a certified passive house. With our prefabricated components, we have obviously a higher quality that also is in the interest of the end user. Resource consumption is very low in a passive house like ours. It's easy to convert. We have seen a lot of changes in occupancy here in this building already. People put in stuff, take out stuff. Everything goes very easy, very smoothly because it's all system-based. Longevity and durability is already proven in timber hybrid construction, and as I mentioned before, it's possible to certify those buildings very easily. So here just some examples from research that, for instance, says that in this wood environment you have increased productivity, you have less sick days. People just feel better and perform better in an environment like this. The picture you see here is from one of our most recent projects. So now let's talk a bit about our international network. If you want to build with Cree, you need experienced partners. And if you want to become an experienced partner, you can just reach out to us on our website. And here are some of the ones we are already working with. So we have licensed partners in Germany, Belgium, Canada, Denmark, Luxembourg, Portugal, Singapore, Switzerland. We even covered Japan, which is now in the works. You will see a project later. We also have signed a contract with an US American company in the meantime. And with another German company. So we now have even multiple licensed partners in one country, which goes along very well also with public tenders, because you know, if you can tender only for one company, it's not going to work well. So this is a map where we currently are. And that brings me to projects from all over the world that I would like to show you, starting with the Life Cycle Tower in Austria. This building has been assembled in just 8 days. The entire building volume was put in place within 8 days. I mean, there were some auxiliary works which took a bit longer, but the main building volume was that quick. And here you see one floor that goes up in 1 day, and the interior fit out can happen right after that. So that's a bit time ago, like 8 years now. Here, a building that has been opened in the beginning of last year, a school in Singapore. Singapore is a concrete country or a city-state. And here you can already see some of the timber beams in the floors. It's pretty nice environment. And the entire gray section that you see here on the facade has been built with the use of the Cree system. It's 12 floors high, so we don't shy away from height limitations. And this is the interior of a classroom. Very minimalistic building services. They have natural ventilation there, even still with the high temperatures in mind, but it works quite well. You have the timber on the exterior wall, you have the timber in your ceilings. It's a very, very nice student environment. This has been the first project in Germany, also opened spring last year. It's kind of perfectly systemized building. Construction time also here was only 8 days, but for even double the size of the LCT1 that I'm sitting in here. So that was 3,600 square meters of gross floor area erected in just 8 working days. Bit of an insight, very nice work environment, I think. This is a project we are currently working on. It's so far the largest one that has been almost completed, 32,000 square meters of cross floor area in Berlin. That's a rendering, how it's going to look like when it's finished. And this is where we are at right now, almost completed when it in terms of structure and shell. It's also heavily covered by media. Maybe you have come along of this already. The next project I want to show you is also in Germany. We managed to contract module 2 of the new Siemens headquarters in Erlangen. This is what you see here in the center. Is 5 of those buildings are going to be built with the Cree system. This is just some glimpse into the prefabrication. You see the walls, you see windows get installed prior to construction. Then those heating and cooling activated floor panels that I had mentioned in the beginning. Just some pictures from the ongoing works. And in the picture on the top left, you see that if you have a quick look, it looks like a concrete construction site, but from the interior, it's almost all timber. And that is the beauty, because the entire construction site is always perfectly protected from the environment. And on the inside, you have perfectly clean timber for a nice indoor environment. That's a project of our Luxembourg partners, also a quite perfectly designed system, floor plan. And here we are still in the ground. They introduced 4 floors of underground parking, and parallel while we do this, the production of the walls and of the floor panels is ongoing. Another project in Luxembourg, which has some beauty because it's also a very prominent building. We have won the competition there, and that shows multiple usage and also the ability to get extended over time. So you can add building parts horizontally and vertically. I mentioned the Japanese in the beginning, so they are working on a quite small project, but they have tremendous challenges in terms of seismic and typhoon resistance. So what they did a hell of a lot of testing. They Japanized, I would say, they Japanized the Cree system to their needs, and are going to build now this a small prototype building. This is a mock-up that they have already done, and it was quite amazing to see these things going up in Japan even. Portugal has been one of our latest license partners. They are also working on a very innovative project, because here we integrate student housing and a hotel for the first time within the Cree system. It's 2 building blocks based on a concrete podium. And this is an example from Belgium, also for residential, designed by David Chipperfield. So there's quite some important architects that have already worked with Cree. There's only renderings available because the project hasn't started yet, as much as this has. I just wanted to show you this because if we always talk about rectangular, you might feel a bit bored if you're an architect, but with our systemized approach, we can also tackle buildings like this, where we managed to bring a repeatable grid into the building. So, do we have still time for the platform? I mean, I'm 1 minute over, maybe quickly. What we currently develop is an online infrastructure which not only connects our license partners, but it also grants access to subcontractors and suppliers and provides all information that you need. If you want to build a Cree building, you can share information, direct Q&A directly to Cree, collaborate with others, share project status. We have introduced a marketplace where we facilitate matchmaking between key stakeholders. We provide services for architects, and the outlook for the next level of the platform will be some multifunctional source of knowledge, of connectedness, of supply and demand. You could even run AI-based analysis over the platform. So there's a lot of functionality coming up before the end of this year. And this helps us to enhance our global network, to make more people part of the Cree family. And that's where I like to end. And thank you for listening and watching.
Thank you, Rainer. It was really interesting presentation. Thank you very much. If you want to learn more about Cree and the system, I think, Rainer, you will be available in the B2B this afternoon.
Yes, I need to check that again because I believe a colleague of mine will be there.
Okay. You will find.
I'm not quite sure about the schedule this afternoon, but you can easily reach me at any time via www.creebuildings.com. As you saw that in the presentation, and you can easily check out our website. It's creebuildings.com, where you also find the link to the platform if you want to get registered. Literally every person on the planet can register at our platform. And yeah, let's keep in touch.
Perfect. Thank you very much.
Thank you.
Our next speaker is an expert. It's one of the leading, or is the leading expert in Ireland and the UK in conservation and stone materials in buildings. Ciarán O'Connor said everybody knows Peter. So thanks for Peter. Thanks for being with us today. I saw that you also worked on very prestigious projects in the UK, the US, and in Ireland. And I'm already curious about your presentation today. But please go ahead.
Okay, thank you, Josef, and good morning, everybody. I think it's still morning where everybody's watching. But my name is Peter Cox, and I come from a chemical engineering and material science background. I started Carrig 28 years ago, and we generally specialize in conservation. But over the last 10 or more years, I've got much more involved also in energy kind of renovation or energy upgrades of our heritage and traditional buildings. And when I say traditional, I mean generally it's a solid kind of masonry wall, although now that we're working also in the States and Canada, we're dealing with timber buildings more and more. But basically it's a building that is generally older than 1945 because post-war construction methods started changing. And if you look at pre-1945 building numbers in across Europe, it represents about 34% of our built environment. So it is a big sector of this industry. And what we've been doing over the last number of years is really researching and developing strategies and methodologies for the correct energy retrofit. There's been a lot of mistakes made by using modern materials, which then creates other problems. And I'll just touch on some of those things. Sorry, how do I move my slide? Sorry, can somebody answer that for me?
I think if you click, it should work automatically.
No, oh, there we go. Sorry. So we have three divisions now, which is the original building fabric consultancy. We also have quite a big wing doing research, and this is working with various international partners on evaluating the effects of climate change on heritage, and also then our energy conservation side. And I've given you a short background. I'll go through some of our experience. We did a gap analysis study for the Irish government on retrofit skills and knowledge. I'll touch on that. And from that, we were asked to develop a CPD course on the subject, which was hugely popular, and we're hoping to run that again. And then more recently, for Historic England, we carried out a study on understanding carbon within the built environment. Some of the projects we've worked on, this is Park Hill in Sheffield in the UK, which is housed over 1,100 families, built in the 1950s of concrete. It became an area of deprivation in the 1980s and was emptied, and it was then taken over by a developer and the local authority to develop into new apartments and social and affordable housing. We did all the materials analysis on this and looked at all the concrete decay, etc. But we decided we could keep about 95% of the fabric, therefore not having any demolition really. This is a model of what it's looked like. The first phase is finished, and we're about to start on phase 2 now. To a very small project, but it's a disused lighthouse on Skellig Michael, which is one of our World Heritage Sites, and this is actually a job that Karin's office is involved in as well. And we're going to refurb and energy upgrade this building into a kind of a facility for guides and for workmen on the World Heritage Site. We were involved in the Tate Modern both phases, phase 1 and phase 2. Phase 1 was restoring the 1950s building, and then a much later addition. And the architect on this was actually Swiss, Herzog and Dumont. But one of our big collaborations, if you like, is we're the Fraunhofer Institute of Building Physics in Germany has a live laboratory in Benedict Beuren. And this was a monastery that was built in the early 1700s. And when I think we first went to look at it in about 2011 or 12, there was about 6 monks rattling around in this that was designed for 2,000 monks and 1,000 lay people. So the Benedictine order gave it to the German government, and the German government have been redeveloping it and repurposing it over the last number of years. But they gave what was called the cooperage to the Fraunhofer. And this is a view of it in the beginning before we did anything. And it's a kind of a T-shaped building. And the Fraunhofer decided that they wanted to create a live laboratory here. So they looked at what can they do, and they created about 12 or 15 different rooms with different systems. We took off the external lime render that was past its sell-by date, and we re-rendered it in a number of different systems. And the beauty of working with someone like the Fraunhofer is they're wonderful on widgets and gadgets, and we could put every monitoring system into this building, which is phenomenal. But if you just look at the restored facades there, we decided that this facade here, we would just put back 40 mil of pure lime render as a kind of a baseline. The front facade then has its lime with hemp added into it as an insulant. And then on this side over here, if I can get my cursor to work, this one then has lime with cork added to it. And then the last facade, we added aerogel with lime render. And this is all within the zone of the original 40 mil thick. And it's and the kind of encouragements to date is quite amazing. The hemp and the cork is working out roughly about similar, about 35% improvement in the U value just within that 40 mil. And then the aerogel is phenomenal. It's showing about 68 to 70% improvement. Now aerogel at the moment is incredibly expensive, so this isn't for every job, but I keep kind of giving an example. You know, when I got my first mobile phone, it was a briefcase, and it cost about £2,500 at the time, and now you can buy them for a tenner and they fit. You lose them in your inside pocket, you know. So I think aerogel is a product of the future, and it's an exciting kind of development. And it means that when you're working with historic buildings, you don't have to change, you know, facades, or you don't have to change. You can use this internal and external. So we have all sorts, it's hard to see there, but we have all sorts of monitoring equipment within the wall. We're looking at moisture movement, we're looking at permeability, we're looking at relative humidity, temperatures inside, outside. And then on the internal, we've used, again, we're kind of trying out different products. We've used an ordinary gypsum wall board, but we're also using calcitherm, I think it's called, which is a lime-based internal lining. And again, here's some of the widgets that we're using to monitor, again, moisture movement, relative humidity, air temperature, air quality as well. And again, here's some of and we do this roughly about every 15 minutes. And this has now been recorded over about a 3-4 year period. And we're, you know, well, Fraunhofer are hoping to publish later this year on this. We've also been working with about 15 major manufacturers throughout Europe to try and either tweak or develop products that are suitable for older buildings, and what we generally term breathable buildings, because if you put, let's say, a closed insulation system such as a polystyrene or polyurethane, then you're changing the dew point and moisture movement, and that's very detrimental to the original building fabric. We're even working with a paint manufacturer where he can add aerogel to it. So a simple painting might improve our U value calculations. The deep energy renovation of traditional buildings was commissioned by the Irish government under SEAI, which is the Sustainable Energy Authority of Ireland, and it was under their research, development and demonstration funding package. And we put forward a proposal, and we won it in partnership with the Irish Heritage Council, the Irish Green Building Council. And we, this is too big to read, but I'll be sending the presentation, which you can make available to attendees later. I can also give you links to the different documents that I refer to. And as I mentioned previously, moisture really is the biggest risk in anything to do with older buildings and particularly with the energy upgrade of buildings. We're working very closely with UCL, the University College London, and they have the UK Centre for Moisture in Buildings. And we're collaborating on a number of different studies there. Which is really kind of informative. What we find the reputable information sources for this subject, which is basically energy retrofit of older buildings. Historic Scotland have done phenomenal amount of work, and we're lucky that we also work with them on certain elements. Historic England, I've already mentioned, where they commission research, but they also produce pretty major documents, which are very, very relevant in this case. And then there's an organization in the UK called Sustainable Traditional Building Alliance, and they have been developing ideas and working, and they came up actually with this product, which is called the Wheel, and it's an interactive online system where you can put in all that sorts of information, and it'll tell you what you can and can't do, or what you should and shouldn't do. And it's a very good basic tool. So it's a good one to play with. And out of our study of the gaps in gap analysis on skills and training, one of our top recommendations was that there should be a pilot study, if you like, or a pilot run with on 10 modules of CPD lectures, and we put a further proposal to SEAI, and we got funding assistance on this. And again, we partnered with the Heritage Council, and we had and the attendance fees were subsidized by the grant that we got from SEAI. And we decided 5 lecture days from November the 1st, 2019 to 31st of January 2020. And the RAI gave CPD credit points, Engineers Ireland also. Unfortunately, the Surveyors Society of Ireland doesn't have that scheme, so but it was phenomenally. We based it on having 100 people attend. Within a week of releasing it, we had 120 applications, and by the time we had to close it at that, and we had 70 people on a wait list. So it was hugely kind of looked for and appreciated. And basically the 10 modules was explaining what is a historic building and what is the climate change mitigation adaptation strategies. And then, you know, understanding your traditional and conservation buildings and conservation principles. And they're mainly based around the ECOMOS charters. And then thermal efficiency and moisture, which is a very important, upgrading building services, low risk, high impact energy renovation, solid wall insulation, and complying then with building regulations and taking a balanced approach. And then to project coordination and risk management and reducing the energy performance gap. And then the last one really was dealing with the knowledge gaps and uncertainties in practice. And we had a great kind of mix of people attended. It wasn't just professionals. There were some contractors and a lot of state employees from different departments, such as Department of Housing and OPW also attended, had a few members attend. And then we broke down each kind of CPD into effectively 3 lectures and had a lot of time for questions and answers, because we felt that's where we were all going to learn more. And we had usually one international speaker and then 2 Irish speakers on each module. And again, I can share the final report on this with you. And so I mentioned ICOMOS. ICOMOS is the International Council of Monuments and Sites. It is the technical advisory body to UNESCO on Built and World Heritage. And I represented ICOMOS International on a European standard committee that was set up in about 2013. We actually produced guidelines for deep retrofit of historically, architecturally, and culturally important buildings. We couldn't quite agree on a smaller title because we had to be inclusive. But that is now standard 16883, EN 16883. And this is the basic matrix that we came up with, that you start with, you look at if you comply, then you move to the next stage. If it doesn't comply, then you do nothing and you walk away from the building, but you don't destroy it. And it's quite a good document, and it was signed off by the 28 states in the back end of 2017. So it's now, we've used this methodology on a number of buildings, and there's very little we change at the moment. So it's good. Social housing in Preston, this is one of the big mistakes that have been made, where they started putting external insulation on nice brick facades, but didn't do it well. Here you can see some of the changes to detail, which is what you shouldn't do with a building. Changing all sorts of you know, the geometry of the building and creating major problems. The scheme in Preston was 300 social housing. They moved the 300 families out, spent roughly about 28,000 per house upgrading it, moved the families back in, and now 4 years later they have to move them out again and spend about 150,000 per house to correct the mistakes that were made. So that's not good for the industry, it's not good for sustainability, and there's going to be a lot of carbon dumped effectively. So we do need to be careful what we do. The study that we did for Historic England on understanding carbon in the built environment, basically we took three case studies.
Could I ask you to wrap up?
Okay.
I'm sorry for interrupting, but
you're fine. Roughly, we evaluated that it takes between do nothing, do a deep retrofit, and to demolish and rebuild. The demolish and rebuild takes 63 years to pay back. So I think I'll just finish there. This is some of the adaptive reuse of buildings and some of the climate change adaptation plan, but I can send you all that. The UN's Sustainable Development Goals, I think, are also important in this area too. So I'm hoping someday we'll get to this carbon crime scene, but I don't think it'll be in my lifetime. Thank you.
Thank you very much, Peter. Very interesting. I personally found very interesting this comparison between hemp cork in aerogel. Not being an expert, but I thought that's really where the future is going. It's really interesting. Thank you very much.
Okay, thank you.
Our next speaker is Associate Professor at the Institute of Architecture and Design at the Technical University in Vienna. Her research focuses mainly on holistic design methods, and the multiple award-winning expert directs the university's master program on sustainable building. Welcome with me, Karin Stieldorf. I saw you before that you were already online. Could you please activate your camera? Here we go. Perfect. Herzlich willkommen.
Well, welcome also from my side. Thank you for the invitation and also the kind introduction. I now have to share my screen. I hope it will be possible. Hope it works.
Yes, perfect.
Works. Fine. Well, again, thank you for the invitation. In my speech, I would like to focus on the topic of sustainability in different construction tasks in cities, in the rural area, in refurbishments, and abroad. Well, okay. Well, how to identify building qualities today? Already centuries ago, the necessary qualities of buildings have been discussed. In Roman times, it was firmitas, utilitas, venustas. Jacques Herzog and Pierre de Meuron say that this is obsolete today and is only a case for the historian or for the speech by the mayor when a new building is inaugurated. Still, they admit that firmitas is an interesting topic for today's architecture. It challenges us to think about how architecture in general is working. What is a floor? What is a wall? Well, there's no easy answer or easy goal to answer for this. Well, researching tradition might help. And it's quite interesting to see where the office of Herzog and de Meuron is. It's an old building. And on the other hand, they construct, you see one of their very famous buildings. It's the Ricola factory building, where they used large areas. I think it still is the largest earth building worldwide, which was constructed with the help of Martin Rauch from Vorarlberg. He's an expert in building with loam and clay. Well, in the end, Jacques Herzog and de Meuron, who came to the say that it is the beauty that enchants us, that makes us curious about life and about ourselves, and that shakes us up and stimulates us. Well, what makes a building a sustainable building in the end? For sure, there are additional qualities that should be regarded beyond energy efficiency and costs. And there is a short summary on the left side. Showing the main criteria of sustainable building assessment, and on the right side for real estate business. And what is important that we have a look on the upper part of this graph, which includes criteria like energy efficiency, building ecology, and even geomancy and feng shui or color design. Well, this is a school by Dietrich Untertrefaller, who won the State Prize of Austria the last time. So the main focus of the award is to ensure that all projects make an important contribution in achieving the climate goals by 2050 and help to further development Austria's building culture. But for a long time, architecture has had not only a functional benefit, but now planners have to meet many more aspects and criteria. Personally, I like this concept of the 5 principles of biophilic design. And there are also architects, as far as I've heard, in the UK who follow these principles, including ecological, affordable, buildings should be innovative, integrative, and also worthwhile. So they also should regard design and beauty. Of course, also the supply with renewable energy is a must if we want to fight climate change. And this shows how big the potential for using solar energy is. On the bottom, you see three winning projects of the Swiss Award last year, showing how interesting solutions can be. And many of them come from Airtex, from Austria, Airtex Solar from Austria. Wind energy is another opportunity in the east of Austria, as it is quite windy there. This is an example of the wind power center built by Wolfgang Reinberg, including the assistance of passive solar energy. Coming to examples, I would like to start my choice with a project for a hospital built by Otto Wagner. He's a famous Jugendstil architect. It is now about to be restored for the Central European University, student homes for them, and further residential buildings. You have the central axe, which is leading up to the church that we will see later. Well, the history of the former hospital area is quite interesting. Vienna at around 1900, Vienna was the fourth biggest town in the world after London, Paris and New York. And the rapid growth of the population also made it necessary to look on the adaptation of the city infrastructure with regard to the mentally ill. They were first kept in the Narrenturm, which you can see here, and then in a palace building in the center, which soon became too small. And since expansion in a central location was not possible, the decision was made in 1901 to build a new institution at Steinhof, which was at its time the most modern campus for mentally ill in the world. Well, now this will be changed. It's no more used as a hospital, but it will be used by the Central European University, which will move from Budapest to Vienna. And Vienna is happy to welcoming the CEU. Well, the goals of the development, I worked on the refurbishment for 1 year together with students and accompanied by a research project where we had a look on the goals, where the goals were first to develop the first Energy Plus refurbishment of a large listed area. It should be an integral design process regarding the location, which is a little bit further up from the center of Vienna, regarding further different kinds of uses. And the project task was a quite wide one in spatial organization, strategies for sustainable and energy efficient construction for historic buildings, simulations. So all these topics should be regarded within the design. Well, this is the church on top of the central axe, which is used quite frequently also by the public. And the strategy to deal with it was first to start with an urban planning analysis and a big picture how to proceed with the development of the area. Then the refurbishment of exemplary student pavilions for students' homes or for university department regarding the height of the rooms within the pavilions, having a look on what can remain and what should be new, and most important also developing exemplary details for the insulation, interior insulation with calcium boards, and of the roof with vacuum insulation, but also for the supply of the buildings. Having further a look on the exterior area, a section showing the exemplary details we worked on, and of course the area also will be supplied by photovoltaics, and this with regard to the listed area. Some examples. This is one of the pavilions that we researched as an exemplary pavilion. There's exterior insulation on the bottom, and one of the there could even be transparent photovoltaics in front of the facade, which could be taken away later, so it would be accepted by even for a listed area. Well, coming to urban residential areas, I developed a catalog of new requirements that are important for housing within the center, which is and some of the very important points are that gardening and food production should be included, that there should be planning guidelines for energy conscious construction, and what is quite new, a massive support primary construction and fill-ins from renewable materials. Some examples. This was a student competition for Vorarlberg in the west of Austria, where the tradition is building with wood and integrated in the pattern of a not very dense town, of the not very dense town of Feld, on the outskirts of not very dense outskirts of Feldkirch. And situated close to a kindergarten, to to a home for elderly people with assisted living, which offers assisted living, and integrating green spaces also in the interior, and a lot of light. A second project for migrants and students was an empty area in the center of close to the center of Vienna. Quite frequently, we still find vacancies within the structure of even of the center of Vienna, and this was an example how to activate the existing building stock, even in different situations where you have regarding that you still have enough sun and light. So all these topics had to be explored even by thermal performance. And this shows that two-story solutions can also be a good way to activate the existing building stock. This was a project for an area of an old railway station which should be activated, which is quite frequently done in Vienna at the moment, to find new uses and new structures for the old existing areas. This was part of this. This shows the winning project of a competition on urban development of that area, and our solution was again research-led, and it shows that how to use this structure of combining massive and light elements, and even leaving empty some areas if you don't need them at the moment. And it also, this solution should also be offered to people who want to be integrated in the building process. One of the important options at the moment, which we also used here, is a so-called activated floor construction, where the heating is included in the massive and storing floor, which is very, which is a very good solution, because there is the argument to use concrete in construction, but it still can be combined with light and ecologic secondary construction. This was, again, this was the research project which was accompanying this project. And we tried out the first elements together with students in insulated these are wall elements and floor elements, insulated with straw and covered with earth. Of course, it could be also other insulation materials. The company that was assisted us was Lucas Lang for that project. They built the temporary parliament, and also in a way that it could be assembled and deassembled and used at another place later. So here you see the elements that were designed by the students and also built by the students. The result, additional result was also a book for DIY constructions as a guideline, which is often for everybody available. This was the production line set up at the factory of Lucas Lang. And this is the project, which has been finished last autumn in Donaufeld, in a developing area of Vienna. This is a picture, a photo on the left side, and showing also the interior. It is an official project of the International Building Exhibition, which starts in 2022, so next year. We're going to rural areas, which are, I would say, a little bit problematic. There we like to use the technique of the big picture to develop visions and to also communicate them to the people of the area. Most important to find out which is the right density and how to include also traditional living patterns and construction patterns. This was one of the a project which is just being carried out at the moment and which shows all this, which shows that traditional elements have been taken up, and density also follows the traditional patterns. Another project that we were asked to deal with was Kirchberg, on the center of Kirchberg and Wechsel, which is a small town in the south of Vienna, a former important town for tourism, but now as it is not working very good anymore. So again, this methodology of a big picture, with this methodology we developed a vision. It was our task was the recovery of the old stock, the revitalization of the town center, to define the living in town center versus space consumption in the undeveloped area around Kirchberg, and the conservation of the green spaces in the center. First thing to do is to use also the technique of walking through areas to really explore them well. And then again, more detailed, the landscape, explore the landscape, the building structure, and the connection or the traffic connections, which should then have a closer look to the center and having a look then how the building in the center can be restored, reused, and also refurbished, concerning thermal performance, but also design and and using still the public area in the center. Now coming, the last part is a series of small houses, which we made for different competitions. This was the winning project of Gaudi, an international students competition, where the topic was to deal with ecological materials. This house was positioned in front during the Biennale in Venice, directly at the sea. Everybody could walk through the house and have a look how pallets can be reused and recycled, even if they're a little bit no more very perfect. So we could walk through and have a look. This is in the meanwhile is a pattern. The system was also applied for a school in Johannesburg. This was a school in the suburbs, and again, pallets were used and more recycling material. Only the sheets on top, on the roof are new because you can't get old ones. From the statics, this was the most easy way to build without companies. This was LISI House, which was the winner of the international competition Solar-Decathlon in 2013. LISI means living inspired by sustainable innovation. The philosophy was to use wood and all parts of the tree, as Austria is a country which has large areas covered with wood. The beginning was to have a close look on the climatic data, which showed that in summer it's approximately as hot, not much hotter than in Vienna, but there's a large offer of global radiation of solar energy, which can be used for the supply of the building. So the concept refers to the Hispanic traditions of Los Angeles, and the patio in the center is a buffer which can steer the income or the use of solar and shading of solar energy. The construction followed modern Austrian wood construction. The building was designed in modules, which made it easier to carry it the long way from Austria to Los Angeles and back. This is how it was mounted together with students. The interior shows how wood can be used also as a very attractive surface in the interior, showing different kinds of wood and different surfaces of wood. Housing technology was a double flow system connected with 2 heat pumps, and the supply of the total area of the house in total was by photovoltaics. And the energy balance showed how far up the plus, it's energy plus billing, and it is really far above zero. The billing is steered by a tablet, which was also developed for this competition with an attractive surface that responds the user by music. It was published in the Architectural Digest in 2018 under the title of Building Physics, Design and the Collaborative Build. And this is how it is set up again in Austria after having been brought back from Los Angeles, now floating on a small lake in the exhibition, in an exhibition area, the Blue Lagoon, south of Vienna. It can also be bought there. It's shown and it's bought there. And I think many of the other producers have had a closer look on this plus energy house. The last project I want to show you is a project.
Karin,
yes?
I'm sorry to interrupt you, but I think we are out of time.
Okay, it's finished. I just go through without.
Okay, Perfect.
And
Thanks.
you can have, I think it's self-explaining, people working, a large roof, shaded areas. And this is how it works. This is my last slide. For me, sustainable architecture matters, and it is even indispensable in the struggle for climate change and a good life on Earth in the future. Thank you for listening, and sorry for being late.
No problem at all. Thank you very much. It was very interesting, and I think it's also incredible how you showed that how your research really went over from a student's project into a really viable project that is now sold on the Austrian market.
Yes.
Thank you very much.
Thank you.
Our next presenter is a serial entrepreneur driven by his vision to create sustainable value for everyone. With a highly motivated team, NEOOM Group creates ecological and economically efficient infrastructure and building systems for the future. Welcome with me, Walter Kreisel, CEO of NEOOM, who is a fellow countryman of mine. He's from the same region in Austria. And as in Ireland, it's always kind of important if you're Carrig man or not. So I'm from Upper Austria as Walter is. So welcome, Walter. The floor is yours.
Thank you to all of you, and thank you, Josef, for the nice introduction. Thank you for being part of it. I hope everybody can hear me. Josef, can you? Okay, very good. So I'm Walter Kreisel. I'm 41 years old, and I'm an emotional entrepreneur, not a serial entrepreneur. So what we like to do to change the behavior of energy consumption. And I grew up in a family where always electricity was in our heart. And so I'm happy to tell you a little bit more about our story. So I found my company a few years ago. I will start to share my display now. Give me 1 second. So, seconds. Yeah. So I found my company a few years ago now, and we converted the company from a system integrator by controlling heat pumps and solar thermal solutions and measurement control systems, mostly driven by sensors, data in buildings to make more energy efficient buildings. And based on that, it was highly much consulting and software developing, but it was really analog business. And that's why we converted our business to a high scalable business based on products. And our products are here for the decentralized energy behind the meter market. And what is the main advantage? So our customers can invest with their money or without their money into renewable energy infrastructure to build sustainable services for the whole real estate market. So, and for that, I give you several ideas what we do. Our company is growing really rapid. So we sold our first product in March 2019. And now we are 75 people, and we had 250% of growth. And we are focusing mostly on the German, Austrian, and Swiss region, and surely focus also on the north side of Europe, where the renewables are really common, and the people understand the business model about it. And for that, I want to tell you what's going on. So the future, we tell the future is knocking on our door. I would say in the post-Corona time, we will see that the climate action will never go back. So the European Green Deal special will skyrocket the decentralized energy markets. Why? So we will have much more wind and solar, and we will have much more new renewables in the grid. But there will be also much more solar special on all our buildings, on all our facades and all our roofs, because we need the electricity on site. So it's sure that 30, 40 or more % of electricity production will be decentralized. And based on that problem, on the volatile energy production, we think we have a solution created where all real estate owners or real estate property managers can hire the revenue and hire the profit based on offering space for living and working and production. Sorry. So 1 second. Yeah. So what is our business model? Our business model is holistic and integrated. We have 3 main departments. One main department is the whole hardware stuff, which you will see later. It's the NEOOM, and NEOOM is the coral as a red-driven color. And on the NEOOM side, we produce products. So we redesign, engineer, and certify home, commercial, and residential, and as well industrial battery storages based on lithium-ion batteries, which is a turnkey solution and highly fast installed, commissioned, and maintained to have the whole energy consumption in the life cycle process as cheap as possible. What means that? What means not only the CapEx to buy all that stuff, also the OpEx to produce electricity and transform and convert it will be very, very important case where we focus on. And surely it's driven by the big ramp up of the electric mobility sector, because all your infrastructure have to be wired and have to be produce solar and on site, and you also have to charge your cars. And based on our energy management solution, we really take care that the buildings can be the next power plants. What means that? So if you produce electricity on site and you store it and you convert it with heat pumps to heat, cold, and with chargers to mobility, and so as and supply your customers with clean, safe, and transparent energy, renewable energy, you can create business models. And for that, you need a software. And the software which we programmed is an edge computing cloud approach, where we predict the 72 hours of the weather forecasts to take care that that how many sun is producing the electricity and how many electricity we still need from the grid. I would say the primary energy demand is coming from the roof or from the facade. That's clear, and it's really cheap. And the rest of the electricity you cannot produce on site is coming from the grid, and it's coming flexible from the grid. And because you store it with your batteries, you produce heat and cold and can store heat and cold as well with your heat pumps. It's based on electricity, and you so as the cars, the mobility as well, and your lights. And if you control all your sites from a decentralized way, your building is becoming a power plant, and it's becoming much more profit because you're running one power plant or many more power plants. And there's one thing also, if you want to install solar panels and batteries and chargers, you have to invest in that infrastructure. You also have to invest in the software. And based on that, with our third division, it's the NEOOM Impact Invest in our holding, is we also source money from ESG and SDG compatible investors. Most of them are pension funds or institutionals. They have really, really low interest on the money, because we can focus with them with our software platform, bring them the projects, bring them the installers, and help them to build smart villages or smart cities, or also big and large enterprise customers and C&I. So based on the hardware and software, you can really run a nice business, which is based on renewable energies and convert highly profit over lifetime. So the CapEx is not a problem. If the OpEx brings a profit, then it's the life cycle on electricity, I would say, is a very, very nice business case. To give you one picture, it's very easy. So the electricity is coming again from the grid. There is coming solar. We can store electricity. We can produce heat and cold, and we can supply our customers with safe energy, clean energy, and very, very cheap energy based by selling services in case of heat and cold, selling services of electricity, and selling services of mobility. And to give you some ideas, I show you also some references. A short how it's looking at the stuff. So a solar roof, a solar facade is very well common, but the batteries in the buildings are really big racks, which you can control over the air by the software. So to give you a little bit more ideas, why you have to invest in such solution. So you reduce the power costs. You generate your own energy and reduce your network usage. You maximize your self-generated power. So what means your storage solutions grow with your company and your requirements. And you can cap your peak loads, what means you don't have peaks on your grid. It doesn't matter if the people are cooking or charging their cars, because the batteries can also shave the peaks. And then also increase the security. So if there is a blackout coming from the grid, your battery, your storage systems secure yourself and your company against the power outages. That is on top. And what means for a car is that autonomous driving software is also a little bit the same in the infrastructure. If you generate a virtual power plant, you can have profit from flexibility of the grid, of your storage in case of energy communities. What means you can share your energy inside of your building with different stakeholders, or you can share your energy if the government allows it, and Austria is here moving on really good. So we can share energy from peer to peer, even from net grid point 5, 6, and 7, what means I can sell the neighbor directly electricity without grid costs. Yeah, and what means electricity is the only energy source which you can really easy produce, store, and convert to other services. But there is sure a very important thing based on the software part. And how is it looking? Again, a solar roof is very easy. And for example, this is one of our customers. He's running 140 shops, and he's owning 30% of the roofs, and of the buildings is his roof. So he's the guy who says, I need electricity for light, for LED lights. I need electricity for heating and cooling. And I need electricity for safer business models in my companies. And that's why he is investing in solar and batteries to create his own power plant, his own virtual power plant. And to show you an example also on an industrial side, because mostly people say, oh, it's solar roof or batteries. This is only small puzzle pieces for the energy transition. And we say clear no. If you see that building, it's also a customer for us. He's a galvanizing plant, what means he is an industrial customer. He have also 400 kilowatt peaks on his solar roof. And he is using batteries like a data center, what means we store close to 400 kilowatt hours also in the batteries, and we can reduce his peaks of the inductive galvanizing plant down to 50%. And here we have a return of invest less than 4 years that it gets paid off. So what means this is really, really interesting, because the money starts the renewable energy is producing money, because after several years, it's going directly in your pocket. So why? Again, you increasing your self-consumption. What means the PV is producing energy, but if you don't need energy, you only can sell it back to the grid, and there is no value. And if you install a battery, you don't have to sell back electricity, and you see it here also. So you have more own consumption, what means you have more profit on your solar investment. And also, if you have peaks, you can drop your peaks, what means you have a safer infrastructure, and you have also lower energy price from the grid if you bring down your peaks on a hybrid application in your infrastructure building. And what means, for example, here is another calculation. if you produce 1 million of kilowatt hours on your roof and you have a battery, what is this is our Austrian prices, for example, brings you 11.8% of a rate of return, what means this is really highly profit after 25 years. So it's even double more than you already invested. So this is really ESG and SDG compatible, what means that the business model probably himself is the main driver, and it's not the ecological aspect all the way. So it's very easy. What do you need? You need a location. You need who is the contact person. We have to know the power loads. We have to know the maximum connected load and the price of the energy. And then it's very easy to calculate to help you all outside to run a business model on top of that, because the solar and the battery creates value and creates profit. And it doesn't matter if it's car dealers, for example, here, they have to invest in their whole infrastructure, because now they can sell electricity directly on their own site. Yeah, from that side, this is looking like a small industrial site or a private site. It looks like, I will share the data. This is how our software looks like. And there is also a future-proofed business model. Think in applications. With a software, you also can count your CO2 consumption. And with the software, you also can connect applications for buying electricity on the stock exchange or buying electricity on the frequency response market. What means your incomes based on your investment in the infrastructure is really driven by high value. So yeah, that's from my side, from NEOOM, and I will say thank you from my side. And we are now in Zurich, in Vaduz, in Munich, in Freistadt and Vienna. And we are, me and my team, and this is our management team and the board, is happy to help you also in your nice country, to bring down the energy costs, to have lower CO2 consumption and make the energy transition possible. And if there are some questions, write me, or you can contact all the time on our website at www.neoom.com.
Thank you very much, Walter. Very interesting insights, and thanks for I don't know, I very much like that you really put numbers on it, because sometimes you just don't get this real hardcore piece, which makes then the technology even more interesting for the clients or potential clients or people who potentially want to partner with NEOOM.
Yeah.
Thank you very much.
Yeah, thank you also. So which partners we are searching? So there are two there's our infrastructure owners on the enterprise side. So they have several sites and want to create a business model around the renewable energies and flexibility. And the second is if there are cabinet builders outside, because we focus on local production. So it means we have our whole license and our software and our parts, and we bring them into the country and can produce it local for local content to help really to bring regionality and CO2 consumption down. So so if you use it or you can produce it, we're happy to work with you all together.
Perfect. I think I have. I also have 2 Irish companies in mind. I'll come back to you. And of course, everybody again use the possibilities of our business-to-business meetings this afternoon. If you want to learn more about the business model and to meet our exhibitors who are available from 12 o'clock.
Thank you.
Thank you, Walter.
Bye-bye.
In our agenda, there was a small change. Thank you, Georgia, for being able to step up and come in an hour earlier. Georgia is the Director and Head of PR Marketing at the International Passivhaus Association. And she's streaming today from Germany. And Georgia, welcome, and the floor is yours. Please go ahead.
Thanks for having me. I will just get my PowerPoint sharing. Can everybody see that? Wonderful. Excellent. Well, as I said, thank you very much for having me. It's really great to be here today. We have a lot in common with Austria and advancing all the work that you do there. You'll hear a bit more about that in a moment. And of course, with Ireland, we have some really great partnerships. So as mentioned, my name is Georgia Tsar, and I am the Association Manager at the International Passivhaus Association, or IPHA for short, which I will call it throughout this presentation because otherwise it is rather a long name. So today I'm going to talk to you a little bit about the history of Passivhaus, what we're working on at the moment, and where we are heading. But first, be good if this changes. Wonderful. So first, a note of celebration. This year, the world's first Passivhaus turns 30. It's located in Darmstadt, Germany, where the first Passivhaus Institute is also located. And it is a terrace house construction that was completed in 1991 when 4 families moved into their new homes. Back then, many of the components didn't actually exist on the market yet, such as triple glazed windows and the ventilation system with heat recovery. So those had to be specially ordered and even DIY'd. Luckily, 25 years on, in 2016, we were able to check all of the building's workings and find out that it is still performing as planned back in 1991. And we then integrated renewable energies into the design to bring it up to a Passivhaus Plus level. So what is particularly exciting about this, other than our first Passivhaus is now 30, is that we have all of the monitoring data from this entire period as well. And as you can see, it is around 10 kilowatt hours per square meter annually of heating energy consumption, which is 5 kilowatt hours per square meter better than the absolute maximum for the Passivhaus standard. So we're performing even better right from the start. The first Passivhaus then went on to inspire a global movement. We now have 2.7 million square meters of total floor area of Passivhaus buildings around the world today. And we also have an entire market for these products, so no more requirements for DIYing these. There's now a wealth of suitable components available. But for some of you here today, you might not be so aware of what the Passivhaus standard is and what a Passivhaus building is. So at the heart of it, a Passivhaus building is a highly energy efficient building. It is based on the Passivhaus standard, which is a quality assured, scientifically proven method to achieve highly energy efficient buildings across and retrofits of all kinds and across all climate zones. There are 5 principles that go into Passivhaus. There is climate appropriate thermal insulation, Passivhaus windows, adequate ventilation strategy, proper air tightness, and a thermal bridge reduced design, so that a Passivhaus building works much like a thermos, keeping the warm air in when you want it in the winter time and keeping the cool air in the summertime when you don't want to be overheating. Of course, that is an oversimplified explanation of what the Passivhaus standard is, and there is a clearly scientifically defined definition with criteria which are available via our website. But the result is the same, a reduction of up to 90% in heating demand and 80% in cooling demand as compared to traditional or conventional buildings. So what sets Passivhaus apart? Well, first and foremost, the Passivhaus standard is performance-based. It is not prescriptive and it doesn't require relative savings. They're very clear, scientifically based and transparent criteria. The Passivhaus standard also ensures predictable energy savings with no performance gap because of this science-based and transparent criteria. And because it is based on building physics, it is applicable the world over. As you may be aware, physics are the same all over the world, which makes the Passivhaus standard not only flexible, but also replicable. Important to note is that it is an open standard. It's not a brand, so it is publicly available, and anyone who would like to take the efficiency first approach and meet the criteria and thus build a Passivhaus can do so. And in so doing, they're also doing their part towards achieving substantial energy savings, which are not only crucial to a sustainable energy supply structure, but also to meeting our climate goals. And what is particularly of interest potentially after our previous speaker is that passive house and renewables are a match made in heaven. The low energy demand of a passive house building makes it easy to achieve more with less. So renewables placed on even a small surface area suffice to cover the majority of energy needs for that building. And the efficiency first approach reduces the costs for energy infrastructure and also helps empower local communities. And as you can see from here, we have the classic, which does not necessarily require renewable energy integration, the plus, and the premium with different levels of renewable integration. So the keys to success. How does one achieve a passive house building? There are three main keys to reaching the passive house standard, and I would say the most important are the people. You'll need a committed team, and often we recommend that they have certifications in passive house designer or consultant training, passive house tradespeople training, as well as a passive house building certifier on your side to confirm that the energy efficiency has been reached and thus provide quality assurance. This can be done with design tools. The passive house planning package provides the energy calculation. It is an energy balance tool that is available worldwide and in a variety of languages, as well as in imperial and in metric units. We also have Design PH, which is a SketchUp based tool, and BIM to PH for building information modeling. And finally, another really important component and key to success are the building components. There are transparent and opaque components, as well as building systems that go into a passive house building, including the ventilation system, the high quality windows, and everything else in between. And once these three keys are in place, a passive house building can be met. We have, as I mentioned before, the plus and the premium levels with varying levels of integrated renewables, as well as the NFIT standard for retrofits. And so the Passive House Institute has created over the decades of its existence a range of seals and programs to help achieve these keys and thus reach the passive house standard. They're not compulsory, but they do definitely make the job easier. So as I mentioned, there is training available, there are programs available, and there are certified components available. A really important aspect of the passive house standard is robust energy modeling. It is an absolute must for reliable in-use energy performance. And as you can see, we have the first passive house building up here on the top with the heating consumption data. And then we also have below a retrofit of a large scale factory. It's a garment factory based in Sri Lanka, which is obviously a hot and humid climate. And so even today, we're still doing monitoring on many projects around the world, seeing the energy usage and making sure that it matches up with the energy modeling that we prepared in advance. Luckily, nowadays, there are thousands of professionals available worldwide to implement the Passive House standard and to ensure this quality assurance that we associate with the Passive House standard. There are thousands of designers and consultants and also tradespeople who are available to make sure the project goes to plan and is both cost and time effective. There are also, as I mentioned at the start, a variety of components available nowadays. So no need to DIY your heat recovery ventilation system. Those are available in multiple countries, and we certified our 1000th component last June. And we even have some really exciting new component certifications, including the first for the very hot climate, which is from Greece and is aimed for climates in the UAE, for example, and also for very, very cold climates, such as those in northern Canada. So I guess the question here is, where does all this work get done? Well, it's not just the first Passive House that is celebrating a big occasion this year, as the Passive House Institute is also turning 25. The Institute was founded in 1996 as an independent institute, and its aim is to bridge that gap between the research and the implementation. The Institute aims to transform the building sector through its research, through quality assurance, through capacity building, and of course through advocacy. There are a wide range of things that the Institute does, but importantly, there is certification of professionals, components, and buildings. There's the development of tools to help make Passive House possible. And of course, there is the research and the training and education. The Institute employs over 60 people from all over the world, including myself, originally from Australia. And we also have multiple locations, which is where Austria comes in. Back in 2010, as Dr. Wolfgang Feist became Professor Dr. Wolfgang Feist at Innsbruck University, we founded a second location in Innsbruck, Germany for the Institute, and they continue to do amazing work today. 2010 was also a really big year for us, as the International Passive House Association was founded. We connect the local to the global by strengthening the Passive House community with networking opportunities, with dissemination activities, and a wealth of other events and opportunities. We aim to bring knowledge to the local level from the Passive House Institute, and of course also bring those local findings to the global level and disseminate them throughout the network. And we're really proud to say that we serve over 5,000 members worldwide in 58 countries, and that we have 22 international affiliate organizations who partner with us, including the Passive House Association of Ireland and Passive House Austria. So here we come to the big aspect of my talk today, this year's campaign. Together with our international partners, the IPHA network has launched the Efficiency First, or Efficiency, the First Renewable Energy campaign for 2021. We're aiming to raise awareness for the vital role that energy efficiency plays in buildings plays in meeting our climate goals, and to highlight that the Passive House standard is global, it is replicable, and it is achievable. And again, to live up to our name and connect the local to the global. And it's not just our opinion either that contributes to this year's campaign. As we have noted, Passive House contributes in major ways to the Sustainable Development Goals. Passive House provides a cost-effective, resilient, healthy environment for building users, and thus contributes to health and well-being. It lowers carbon emissions through high energy efficiency to help combat climate change. It makes use of renewable energy sources to improve access to affordable and clean energy. It provides jobs throughout the whole range of building professions, from manufacturing and construction to design and development, and thus creates opportunities to boost the economy. The Passive House Standard and the Institute also work hard to educate professionals and the public on the role of buildings in climate action and achieving better buildings. And we share this knowledge internationally through the International Passive House Association. And Passive House provides quality assured buildings using a transparent performance-based standard, which ensures accountability for meeting our construction and climate goals. And finally, a question that we so often get, we create and grow a strong international community and partner in climate protection and better buildings. And we're always looking to expand those partnerships and find other crossover studies with different institutions worldwide to really show the importance of energy efficiency. You may also be aware that the UN's IPCC has stated that we need to enormously reduce our carbon emissions if we are to meet our climate goals. And it's a study that came out in late 2020 from the Global Alliance for Buildings and Construction. We found that 35% of the global share of final energy use comes from the building industry, and that the bulk of this is used in the operational stage of buildings. And as you may also be aware, the operational stage of energy use is almost, the majority of this is almost exclusively coming from heating and cooling demand. And that's really where Passive House shines, because that's what we reduce. However, I do accept that for the individual, looking at the Sustainable Development Goals and the IPCC might not hit home. Luckily, the associated benefits of building better exceed the environmental benefits. Certified Passive House buildings also achieve a high level of comfort as, they achieve a high level of comfort as they're optimally insulated for their local climate and create a consistent, comfortable and healthy indoor environment. They provide consistent fresh air through the ventilation system with heat recovery, caring for the comfortable indoor temperature. And this is particularly important in the times of Corona, as these systems also come with filters. Passive House buildings are also built to last, as they're resistant to moisture buildup and mold damage, thanks to their great air tightness and high quality components. They perform as planned because the planning tool, as I mentioned before, PHPP, ensures a reliable energy balance, and thus there is no so-called performance gap between the planned energy use and the real energy consumption of the building in operation. Passive House buildings can also be designed as desired, as it is a performance standard without a specific construction method, which leaves designers free to choose how to meet the energy performance criteria. And finally, Passive House buildings are cost effective. Over a building's life cycle, a Passive House building is more cost effective than a traditional or conventional build, thanks to its extremely low energy demand and maintenance costs, and thus low operating costs. The activities as part of the Efficiency First campaign are planned throughout 2021 and will include a range of talks and information sessions, print and online publications, the International Passive House Days, and so much more. You can find out more under the hashtag Efficiency First throughout social media or via our website. So finally, So a Passive House building, as we've learned, provides an existing pathway to meet our climate protection goals. And there is a passionate and a prepared global community ready to implement best practices, and thus reduce operational energy and emissions in new and existing buildings all over the world. So finally, if you're not yet convinced, why Passive House? And I would ask, why not? There are international criteria that are applicable to a variety of building types. It is a scientifically proven method for achieving better buildings that are highly energy efficient with no performance gap, and there are both capacity building and market opportunities available worldwide. Passive House buildings can be built to any shape and for any size, including an entire district or a tiny house, or even skyscrapers. They can be built for any function, including museums, supermarkets, schools, swimming pools, hospitals, factories, and even religious buildings. And most recently, an enclosure for the hippopotamus at the Munich Zoo, or potentially Berlin Zoo, but a zoo nonetheless. And they can also be made for any budget and any construction material, according to local preference or, of course, cost restrictions, including the straw bale house here on the right, wood, which is very popular in Canada, for example, or earth or masonry construction. And finally, Passive House buildings can be met for new builds or retrofits. So the important thing here is to think efficiency first and then just set your creativity free. There are a wealth of free resources available via our website or via Passipedia, the Passive House Wikipedia tool. You can also take the Passive House for Decision Makers course, which takes about 25 minutes and is completely free. And there are, of course, a range of blog articles and videos available on YouTube and, of course, the IPHA blog. You're also most welcome to join us at our 25th International Passive House Conference, as you might be getting the feeling, the 2021 is a big year for Passivhaus, and our conference will take place as a hybrid event, both online and live in Wuppertal, Germany, from September 10th till 11th. And of course, you are always welcome to join IPHA as a member. There are a wealth of benefits to doing so. We'd highly recommend that you join through your local affiliate organization, which would likely be Passivhaus Austria or the Passivhaus Association of Ireland, and thus you'll get a 2-for-1 membership, with the IPHA membership being free on top of your local membership and member benefits. So finally, we do really hope that you'll join us in the goal of achieving comfort and health in our future buildings. Please think efficiency first on your upcoming building projects, and thank you for your attention.
Excellent. Thank you, Georgia. All the best for the next 25 years, and you have a great year of celebrations ahead. And I see you also trying now hybrid events, as everybody's doing at these times. Even I have to say, I look forward to be back to events in person. I just cannot wait.
Certainly.
Thank you very much. Our next speaker is a building energy expert with experience and training both in Ireland and Spain. Currently, she works on the SEAI Exceed program, providing grants for excellence in energy efficiency design. Marina, welcome to our event today, and thanks for taking the time. Please go ahead. The floor is yours.
Thank you, Joseph. Thank you very much for inviting me. I'm gonna share my screen so you can see the slides. Can you confirm me that you can see it right? Perfect. So, well, good morning, everyone. Thanks also to all of you for joining us today. I'm going to present some of the supports that we have available in SEAI. The focus of today's presentation will be the Exceed certified grant scheme in which I'm working. However, at the end of the presentation, I'll also give you a brief overview of 2 other supports that we have available for companies. Here is a look at the agenda for the Exceed presentation. I'm going to start with a high-level overview of what is Exceed, what is it, who is it for, and why you should be interested. I'll then have a brief look at some case studies showing how organizations have implemented Exceed within their projects. I'll then bring you through some of the sectors that have benefited from the scheme, the average savings that they have achieved, opportunities that they've implemented, and then I'll explain how to apply, and I'll finally finish with some quotes from past participants. So what is Exceed? Well, for those of you that are not familiar, it stands for Excellence in Energy Efficient Design. Exceed is first and foremost a standardized methodology for energy efficient design. It's based on IS 399 standard, and it's applicable to organizations that are making a significant investment in an asset. It can be a new build, a major renovation, or a major energy upgrade. And companies can achieve Exceed certification of their asset. And as you can see in this picture, this is the Exceed plaque that companies will receive once they become Exceed certified. Just to give you some further context about Exceed, it was this grant scheme was launched in 2016 as a pilot, and as you can see, it has now reached all the 26 counties in Ireland. On the left, you can see some figures showing the combined impact of the projects that we've supported to date. We've achieved about 85 gigawatt hours of annual primary energy savings. That corresponds to about 6.7 million in energy cost savings annually, and about 27,000 tons of CO2. So who is it for? Exceed is for organizations that are making a significant investment in an asset, as I said, and it can be a completely new build, a new or an existing process, or a major renovation, or a major energy upgrade of an existing building as well. Why should you all be interested? Well, first of all, we have 14 million available this year for Exceed grants, and we are expecting similar or higher levels over the next couple of years. We can provide Exceed grants of up to 1 million per project. But I have to say that even without the grant, the EXIT approach to energy efficient design makes good business sense. EXIT sets out a clear process to help organizations design for optimum energy performance. So it's going further than just looking at a more efficient and boiler to replace, for example, but it's actually looking at the full range of energy uses that we have in an asset. So we can be looking at heating, cooling, ventilation, refrigeration, compressed air, all of that. And by helping companies identify the best opportunities specific to their asset, EXIT can reduce the energy bills and the associated carbon emissions. This can increase competitiveness, and as you saw in the EXIT plaque earlier, it also shows a commitment to sustainability that can help boost your green credentials. The diagram that you can see in this slide shows the potential for investments over time. The blue line shows that right at the beginning of a design project, the saving potential is very high and the associated investment cost, which is the orange line, is low. However, as we progress beyond the design phase of the project into procurement, construction, and commissioning, then the saving potential decreases and the cost of making energy saving investment increases. This is basically because of the lock-in effect of building something inefficient. So once an asset is built, it is expensive to change it. This basically emphasizes the importance of considering energy efficient design as early as possible in your design project. The sooner that you begin, the greater the scope for significant changes. In terms of the supports that we have available, there are two stages in EXIT. The first stage is the pre-investment stage, and typically this involves the fees for an energy efficient design expert to undertake some of the EXIT studies. And this is basically to ensure that the project is going in the right direction so that your asset will have a good energy performance. The maximum grant available that we have for stage one, it's 50% for large organizations, but it increases to 60% for medium and 70% for small companies. And then we have the second stage, which is the capital investment stage. The stage 2 support is available for the incremental costs above and beyond your baseline, and also for the investment professional fees if they apply. The maximum grant that we have for stage 2 is 30% for large companies, but again, it increases for medium companies to 40% and small companies up to 50%. This slide is just to give an overview of the types of expenditure that can be supported. At stage 1, we'll generally see ED expert fees, but depending on the project, there may be other types of fees too. And at stage 2, we've included here some examples of the type of equipment that has been supported to date. But generally, any opportunity that will deliver energy savings is eligible, along with the associated installation costs and the professional services if it applies as well. Now, I'd like to walk you through some of the EXIT case studies. The first one is Dublin Airport Authority. They went through the EXIT process for their Dublin Airport car parks, and they have now achieved EXIT Managed certification. They found that EXIT helped them to achieve very substantial reductions in energy use, about 80% energy savings, as you can see. And not only that, but the project also brought a number of co-benefits, including reduced maintenance and improved lighting quality in their car parks. You can read the full case study that we have available at the link here provided in case that you are interested. In any EXIT project, including this, the one about the Dublin Airport Authority, the two roles that are shown in orange in this image are critically important. One is the energy efficient design owner. This is someone within the organization with responsibility for ensuring that the ED project is implemented. And they report directly to the top management and will also be the lead applicant in terms of the EXIT grants. The other one is the energy efficient design expert, or EED expert, who is independent from the design team, and they report directly to the EED owner. They have responsibility for leading on a suite of pre-investment studies, which I'm going to look at in the next slide. So in terms of when we start our journey in EXIT, one of the first steps is to identify the baseline design and carry out an energy balance study. This will help in identifying the significant energy uses that we have within the asset. Once these have been identified, the next step is to carry out a challenge and analyze exercise. This involves challenging each of these energy uses against each layer of the energy Venn diagram that you can see on the right, starting in the middle with the energy savings and energy service, and going through process, equipment, control, and so on. For the Dublin Airport project, they challenge the car park lighting energy use by asking questions such as the one that you have here. For example, do we actually need to have lighting everywhere? So through this process, a range of opportunities are identified for energy savings within the asset, and these then are subject to analysis to understand their potential impact. It's by applying the reward of this standardized approach that Dublin Airport Authority were able to design and implement this complete transformation of their car park lighting. I also wanted to show you quickly another example. In this case, it's a new build. It's Johnson & Johnson Vision Care. They apply the exit approach to a new gym and medical center. And this resulted in a building that is 25% more efficient than building regulations. Again, you have here the link to the full case study in case that you want to read it through. Now, I'd like to go through some of the sectors and opportunities supported by Exceed. Here you can see the, sorry, the 14 organizations that have achieved Exceed certification of an asset. And I know that there are many more going through the process of becoming certified. You can see that both Dublin Airport Authority and Johnson & Johnson are included here. I just included this table to show you that Exceed can be applied to a wide range of asset types and project types. You can see that there's a mix of new builds, renovations, major energy upgrades projects in here. And also you can see the types of projects that they include offices, leisure centers, health facilities, manufacturing plants, for example. So it's a really wide range that we are having in Exceed. Offices may be one of the sectors that is relevant to the audience today. We've supported 7 office projects to date. Significant savings have been achieved in this sector, and a wide range of opportunities type have been supported to date. You can also see here the average savings that have been achieved and the average payback with and without the Exceed grant. We've also supported 9 leisure projects to date. This may be of interest to some of you, and here you have the results that they have achieved. Just to mention that we've also supported projects across a wide range of other sectors. So if any of you are interested in details of a sector that it's not covered here, please feel free to ask and we can provide all these details. Now, how to apply? Well, as we saw earlier in the presentation, the earlier that you begin your energy efficient design in your project, the better. Once you know that you are just planning a project, you can apply for a stage 1 grant support for Exceed. You will need to appoint an energy efficient design owner from your organization, and that they will be the lead applicant for the grant, and they'll have responsibility for ensuring that the energy efficient design is implemented for the project. You will then have to identify a suitable EED expert for your project and then complete their stage 1 application. It will take, then that's bring to SEAI, and it takes us to up to 3 weeks to issue what's called a grant letter of offer. Once you receive this letter, and you can get your EED expert to start carry out the Exceed studies. Once these studies are completed, you will end up with a comprehensive list of opportunities, of type of opportunities that are suited to your asset. And then when you've made a decision on which ones you would like to invest in and to implement, you can submit a stage 2 capital application for capital grant support. It will take us about 4 to 8 weeks to evaluate this stage 2 application. And once you receive the letter of offer for this stage 2, you can start the implementation of the capital investment opportunities. Just to mention that there's actually no requirement to apply for a stage 1 grant. So if you have already done the Exceed studies, you can directly apply to stage 2 because these studies are needed as part of your stage 2 application submission. This slide is just to set out the high-level eligibility criteria. Grant support is available for projects that follow the exceed energy efficient design process. We can issue grant offers in 2021 for works that will be completed by 1st of October next year, so in 2022. And exceed grants can only be used to support opportunities that are making progress to national climate policies. So for example, fossil fuel upgrades are only eligible in exceptional cases. Value for money, it's also important. We can only support projects with a payback period greater than 2 years and less than 20 years. And we only support projects where the asset's annual energy consumption is 100,000 kilowatt hours or greater. That would be approximately 10 to 20,000 euro per year energy bill. Under state aid rules, we can only support projects that actually need support. We cannot support works where the grant will have no impact. Full details of the eligibility rules are set out in the Exceed Grant Scheme Guidelines, which are available on our website. This is a comprehensive document with all the information you will need before applying. Our online application form is also available on our website, and we have an instructions manual and a PDF version for reference. Our contact details are here, so feel free to get in touch with us if you have any questions at all. And now I'd like to show you some quotes from previous grant scheme participants. I think these are helpful in showing the impact that Exceed can have in real world projects. I'm not going to read all them now, but you will have these leads available so you can go through that. And now I'd like to briefly mention the two other supports that we have available in SEAI. First one, it's the support scheme for renewable heat, or SSRH. This scheme has been developed to incentivize the shift away from fossil fuel heating systems to renewable heating alternatives. For heat pump installations, there is a grant available for 30% of the investment cost, or there is a 15-year tariff payment available for heat generated from biomass and biogas boilers, or CHP. This paid is for each kilowatt hour of useful heat generated and used. The scheme is open to a wide range of non-domestic sectors, but please note that it doesn't apply to sites under the emission trade scheme, the ETS. In terms of requirements, the principle of energy efficiency first applies. This is to ensure that buildings and processes are efficient enough to be able to benefit from renewable heat and to minimize the amount of heat needed. Biomass and biogas installations must meet quality standards for the feedstock to be used, and they will also be subject to ongoing metering throughout the 15-year period. There is a cost indicator and a suitability survey form on our website to help businesses understand whether their site may be suitable and what the numbers look like in terms of potential cost and savings. And I just want to briefly mention then the other scheme that we have available. It's the Energy Efficiency Obligation Scheme, or EOS. This one, it's not a grant support scheme, but rather it's a legally binding obligation on the largest energy companies in Ireland to deliver energy savings each year by supporting homes and businesses to improve their energy efficiency. The energy companies with these obligations are listed in this table, and their contact details are all available on our website. The targets that are shown here relate to the 2014-2020 compliance period, but note that the new period just started the 1st of January and will run until 2030. Another important thing is that as this is a grant scheme, it's possible to get EOS support in addition to the SEAI grant support. So that means we can get support for EOS as well as Exceed or SSRH schemes. Finally, the types of support available are shown in these two tables, and they can include financial support, technical support, or a mix of both. Note that the supports don't have to be from your own energy supply, and you can get support from any of the obligated parties that we've presented in the previous table. And that's it for my part. Thank you very much for attending today. Our contact details are here, so if you have any questions at all, please do get in touch and we will be happy to help you. Thank you.
Perfect. Thank you, Marina. Really interesting insights. And yeah, we're doing quite some, or we'll be having planned some webinars with the SEAI to inform also Austrian companies on what projects are upcoming. And yeah, thanks again for taking the time today.
Perfect. Thank you very much, Joseph.
Thanks. Our next presenter is already online, I was told. He has years of experience in delivering high quality solutions for the insulation of buildings, mainly talking about doors and windows. He's Andreas Zimmer, Managing Director of Internorm UK and Ireland. Could you activate your camera?
Yes. Can you hear me?
Yes, I can hear you now. Yes.
I'm just having issues with my camera. For whatever reason, I can't activate my camera. Zoom is unable to detect a camera. This is very strange. So I've got technical issues here at the moment, which I don't know why.
Well, as a camera, try to activate the presentation.
Yeah.
It's the more important bit, I think. But
I'm not sure if you can see the presentation.
No.
Okay. I will try to share my screen. Let's see.
Yes, now something is moving. That looks good. Yeah, you're all fine. You have to go in the full screen
yes
mode, and then you're good to go.
So can everyone hear me?
Yes, it's good sound.
Okay. I'm sorry for the technical problem. It worked well till 5 minutes ago, but for whatever reason, something went wrong. First of all, thank you very much, Josef Tremor, for the opportunity to talk about Internorm, to talk about Windows, efficiency of Windows. Thank you very much for the invitation. My name is Andreas Zimmer. I'm the Managing Director of UK and Ireland for Internorm Windows UK Limited. And I would like to introduce you to Internorm. Internorm is an international family business, and we are established 9 years ago in Austria, in Upper Austria. So like Mr. Tremor, I'm myself an Upper Austrian. The headquarter that you can see on this picture is near Linz, which is the capital of Upper Austria, and we have our headquarter there, and also our one of our factories connected. We had our 90th anniversary last week on the 24th of February, and we had an online event. Normally we would celebrate this together with a lot of people, but for obvious reasons we couldn't do it, so we tried to do it online. We are also a member of the AFN group. This is an international group that was established early 2000, and the purpose of the group is to have companies with the background of windows, doors and facades and shading. And at the moment the group is altogether is eight different companies, and one of them, the biggest one, is Internorm, and the group itself is now, like I said, eight companies altogether, 5,000 employees and around about 700 million turnover in euros. We as Internorm are one of Europe's leading window brands. We're not the biggest manufacturer, but we are one of the leading window brands if it comes to energy efficient windows. We so far manufacture 26 million windows and doors in our 3 factories in Austria. In Upper Austria, we have 2 factories and 1 factory in the south in Styria. Like I said, 3 production sites, and Internorm only is round about, we employ 1,900 people. So we manufacture and deliver to the end customer via a distribution network this is established in 21 countries all over the world, but our focus is still Europe, and it's more or less 1,300 partners in Europe, with exception of other areas over the globe. Internorm itself, 380 million turnover last year, so that's some of the figures. The British market was established in 2007, and in Ireland we started in 2011. So UK is now this UK subsidiary is now 14 years old, and we're based in North London, and we at the moment still we support our distribution network from London across the UK and Ireland. Okay, I want to talk to you about improved efficiency in connection to winds today, and three main topics I want to cover. The first one is heat, thermal performance. The second is sound, acoustic performance. And the third is light, and this is solar gain. So let's dive into this. And here you can see a very interesting picture that should illustrate the topic with heat. Heat, superior thermal performance means superior comfort is obviously a reduction in the carbon footprint. If you look at the left, it's an old double glazed, a house with old double glazed units, and the red color illustrates the heat loss that you can clearly see. Whereas on the right, this building on the right illustrates new triple glazed units, and I think the difference is obvious. The heat loss is close to nothing. So you can see the benefit straight away, and that's, I think, is an enormous achievement. Now, the second topic, which is very important more and more these days, especially when we talk about globalization, big cities, is the cut and noise, acoustic performance. This is sometimes even more important than other topics. On the right, you can see a graph where you can see the sound meets the glass obstacle. So sounds emitted, sounds reflected, sounds transmitted, and in between you have an acoustic interlayer where obviously you get the performance of what we call decibel rating. How to improve acoustic performance? So a couple of things. First of all, you can go to triple glazing. You can improve the cavity depth. You can change the glass thickness, and last but not least, laminate the glass unit itself. A few figures to illustrate what I mean by that. If you go for a standard double glazed units these days, which are still very common in the UK and Ireland, you have an acoustic performance of around about 29 decibels. If you go for a standard triple glazed unit, then you can achieve 35 decibel. Internorm is now up to a decibel rating of 47, which you can achieve with superior triple glazing. You have to do a couple of things, but that is more or less the maximum that you can achieve these days. And I have to say this is an enormous achievement. I would like to invite you, as long as it works, with a short video to illustrate, and I hope it works. So hopefully everyone could hear the difference. Triple glazed unit. This was, by the way, a standard triple glazed unit with a rating of 35 decibel, and we simulated with the sound. You open the window, you close it. The difference is obvious and significant. Now, the next topic is light, and light is always, especially these days, still where it's getting dark early, and in the morning it's still dark when we move. Usually when we move to office or when we go home at night, it's always dark. So the improvement of the overall well-being is important for all of us. Just a few things to this. Conventional insulated glass absorbs up to 30% more daylight than compared to premium coating. E-Class is something that we established together with our supplier Saint-Gobain, which is one of the biggest float glass suppliers in Europe and I think worldwide. And this is very important because it gives you more light, 77% more light transmission, and up to 10% more daylight, which is really, really important for the well-being. Also, the energy efficiency, 60% more solar gain, so you get more heat, if you like, natural heat into the building, so you don't really need to heat the building as such. And on the other hand, up to 11% less CO2 emission. So this is very good. Improved living, I said before, more natural light, which is for all of us very, very important, and a reduced heating bill. Yeah. Okay. Now a little bit about innovations, and Internorm, we call it internally, we call it ITEC, Internorm technology, so innovations. I want to just cover briefly three topics here. One, briefly mentioned, is shading. We have a solution which is basically completely can do something without any power. So you don't need to put any power in this product. It's an integrated photovoltaic cell, which means no energy costs. Even in winter time, a solar gain, you can do this with a day-night adjustment, and you can control it via your mobile phone, your smart home technology that is now these days in your house, in your building. The second one is glazing again. ITEC glazing, what means that? The glass is now bonded to the sash, which means it gives an improved stability to the window. Older systems still have steel for stability, and steel, as you know, is not very, very great if it comes to insulation. On the other hand, obviously, excellent thermal insulation and sound reduction. And on top of it, it improves the security as well, because a burglar, it's very unlikely that they can go through the glass into the building. ITEC insulation is something that we established years ago. We don't use any foam as such. We use granulate instead, and we can distribute this even into the cavity because we blow it into the frame, which obviously then improves the thermal insulation. So that's the three main things that we from Internorm cover at the moment in terms of innovations. So another thing is I'm pretty sure we've got a lot of participants today that are architects or planners, and the big trend that we can see in Europe, in the UK and in Ireland is large scale glazing. But it's obviously great to have a lot of, I told you, there's a lot of light coming in, solar gain, everything, you name it, this is all great. But there's a bit of a downside to it, because you can overheat the building as well if you're not clever with the glazing solution, or in this case, with the shading solution. Now, what I want to illustrate here with this picture, on the left, it's a normal building, no shading, the heat is coming in through the glass, and it can, to a degree, overheat the building. On the right, as we call them, rough stores, or it's an outside shading system that we produce in one of our factories. It gives you a one-shot solution, and you can actually improve the room and bring the temperature down accordingly. And on the next slide, just to illustrate it, if you can do this in a clever way, which you can control again with smart home technology, with your mobile phone, or with a sun sensor, it can reduce the temperature by up to 10 degrees centigrade, which is obviously quite a lot. And just a few other bits that I want to illustrate. To cool a room by 1 degree centigrade with air conditioning uses 3 times more energy than heating it by 1 degree centigrade. Up to 30% less energy consumption, passive cooling and solar heating. One effective shading solution can save around 8,500 kilograms of CO2 in its lifetime. This is maybe, you know, what does that mean? It's a lot. It's actually a lot. Just if you improve your shading solution. In its manufacture, use and disposal, it only generates around 150 kilograms of CO2. So I think if you calculate, if you see the calculation, it explains itself. Very important, last not least, is the correct placement of large-scale windows in the building. That's where the designer, the architects come in, and if they do this in a clever way, it can achieve so much more. Okay, here a very simple thing about capital versus full life costs. So a standard window versus a performance window. Standard windows, as you know, are expensive when you buy them, but they're not very thermally efficient, and it maybe comes with a higher monthly bill, and you know, needs replacing maybe after 10 or maximum 15 years. If you go for a very high performing window, of course you have to pay more when you buy them, but straight away when they're installed, they can save you money every month. And the lifespan of it is much longer. An internal window, a standard lifespan is between 30 and 35 years. So the payback plan, if you like, illustrated here, starts after 3 years, which is not really a long time. And I think if you think about this for a second, I think it's obvious that yeah, to invest in high-performing windows makes a lot of sense. Not because I'm from the industry, but in generally speaking, it can achieve a much of the payback plan. So, okay, next one is sustainable windows and doors. Just to illustrate a couple of things, we from Internorm doing a lot in-house. We design and manufacture our own composite windows with timber and UPVC. I know from discussions with architects and planners, UPVC sometimes got a bit of is a bit negative affected because of raw materials that the industry is using. The positive thing is, if it comes to Internorm, we have the whole process completely under control because it's all in-house. We are one of the leading manufacturers in Europe that extrude our own material, and when we extrude, we obviously can recycle. We can use recycled materials at the same time. We can't use it on the surface, but in between the product, we use already a lot of recycled material, which is very good. So basically, old windows are coming to us, we recycle them, and we use the granulate again to produce new windows. Timber itself, I think, speaks for itself. We only source from locally, and timber is a resource that a source that we can use, and is a very sustainable one. To explain this a little bit more, a bit of the cycle. What do we mean by that? We have the sustainable production cycle. Like I said, locally and responsibly sourced raw materials. We have our in-house production, windows, doors, glass. We do our own glass. We just get the flow glass, produce our own glass with our own profiles, with our own extrusion. We try to, the waste heat recovery is very important in our factories. So we use the energy that would be wasted usually to produce stuff for heating, for example, which is a reduction of energy as such. We have a very smart logistic process. I told you we are focused on Europe. and we deliver our products across Europe. And it means that, for example, a smart solution is that we put this in containers on trains, not on lorries, which is very important to bring down the CO2 emission anyway. And end-of-life recycling, I mentioned this earlier, timber, UPVC, aluminium comes back to our factories. We put this into a recycling method and use it again. And this is very important for our company. Yeah, integration of recycled UPVC in new products, to give you one example. Yeah, a quick reminder. We're all working on the Climate Act 2008, which means 80% reduction in carbon emissions relative to 1990 levels to be achieved by 2050. I don't really know at the moment where we are, but what I can see, we're talking a lot about electric cars these days and CO2 emissions and diesel cars and all these kind of things. But the bigger impact will be on the improvement on our buildings, especially in the UK and Ireland. We have a very old building stock. It's old buildings and they're not very efficient. Just to talk about the improvement that we can do on windows and doors, and it's other things that we need to do. It's not only windows and doors, obviously, but to insulate the buildings accordingly. Yeah, put triple glazed windows in it can reduce everything, the utility bills, reduce the carbon footprint, you name it, the whole thing. And then I think we are able to achieve these levels that we need to by 2050. I think the buildings are the key to achieve this. A lot of, like I said, a lot of focus is on the traffic, but at the end of the day, the buildings, we have millions of buildings across Europe, and I think that's where we really could make a massive impact. Okay, last but not least, another video that I want to show you. I'm not sure about if you know Charlie Luxton. He's an architectural designer, and he got just a few things that he want to talk about, which makes difference in his home that he designed by himself. So hopefully, oh no, that didn't work for whatever reason. Apologize, but there's not a problem. We have here our contact details, and my account manager in Ireland, Andrew Aitchison, will be on the afternoon session anyway, and whoever wants a video or a link to our presentation is more than welcome, and we'll give this information, we'll deliver it. Okay, I'm at the end of my presentation. Again, Josef Tremel, thank you very much for the invitation, and I'm not sure if I gained some time.
You did perfect. You okay. Were just on time. It took you maybe 19 minutes. It's perfect. Thank you very much for the time.
Thank you.
And looking forward to working with Internorm in Ireland, and certainly also talking with Andrew in the future on the Irish market.
Thank you very much.
Thanks. Could you close your presentation?
Yeah.
Perfect. Our next presenter is the CEO of an internationally operating SME active in construction and environmental technology. When I read about an award they won in Austria about recuperation of energy from water and technologies on water saving, I thought immediately of Ulrike Rabner-Koller and to ask her to present at today's event. She just came off a meeting with the European SME Union, where she's still vice president or president. And I'm very much looking forward to a presentation today.
Yes, so thank you very much for inviting me and to be able to give a presentation on our technology for heating and cooling with renewable energy, this wastewater energy. And I will now open my presentation. And okay.
Yeah.
Yeah, so a few words to our company. So we are actually international active, and I'm running the company in the second generation. My parents founded Rabmer in 1963, and we are basically active in construction and real estate, municipal service, and environmental technology and renewable energy. So on the last sector, we are concentrating since more than 30 years now. And we started by then with pipe rehabilitation in Nordic, and we were pioneer with this in Europe. And we then enlarged our portfolio. And we are now concentrating on one hand on energy from wastewater and exhaust air, which I will go into detail then afterwards. But we are also having a product for lime and corrosion protection. We are also offering eco-turbine water and energy saving for showers, which actually offers 40% reduction of water and energy without any negative effect on the people who showers. So this is very important for example, the hotel sector, but also for companies, and also, of course, for homes. We are all active also in water treatment systems, of course, still in Nordic pipe rehabilitation, also in rehabilitation of manholes and tanks, and also active in smell stop systems for sewer manholes. So why are we actually active in recovering heat from the sewer system? As we are concentrating on sewer for a very long time, we actually realized, okay, the sewer itself has always 24 hours and 365 days a year, the same temperature. And especially if you look into these figures now, that every year almost 50% of the total energy consumed in Europe is used for the generation of heat for either domestic or industrial purpose. And if you go into the domestic sector, there is 42% of the energy needed for the heating, 16% for cooling, and 5% for the warm water production. You see that 73% of all consumed energy in the domestic sector is actually going in heating and cooling of the buildings. And so therefore, for us, it was important to look into a different way on heating and cooling, and a renewable way for heating and cooling. And basically at the moment, most of this heating and cooling energy is based on fossil fuels, such as oil, gas, or coal. And so to reach really the European and the national climate change goals, we have to use renewables for heating and cooling of buildings. And there are several technologies available. One is the solar thermal solutions, there is biomass, there is geothermal, there is energy exhaust from air, and energy from wastewater. And why energy from wastewater? As I have already said, it is 24 hours and 365 days a year available. Wastewater is renewable energy, also since 2018, stated by the European Commission and the Parliament, and it has relatively high temperatures for further use. So in the urban sewers, it's between 12 degrees and 18 degrees, and when it comes to industry, we have up to 30 degrees and more sometimes. So the technologies which are used are tested and matured now, and studies in Germany say that actually 10 to 14% of the heat demand in the building sector can be covered by energy from wastewater. And of course, it is brings reduction of CO2 emissions and also of operating costs. And the payback periods are less than 10 years now on a realistic way. So the areas of application starts from the shower facilities. There you can also install heat exchangers below the shower tray. And the cold water is being preheated from approximately 10 to 24 degrees. And so you can save energy from about 30% already. Then there are in-house solutions. There we actually gather the water coming from, for example, the industry process water, but also businesses, hospitals or hotels. And then it is also used for preheating the water consumption there. And then there is the sewer application. There it is really the big systems where you can heat and cool buildings and quarters. And there are different applications actually. There is the application where you put the heat exchanger in the sewer. Then there is an application where you have the bypass solution. And then there is also an application for the sewer treatment plants. And last but not least, there are cold grids and district heating systems where you can actually include the wastewater heat into those heat networks. So the in-house solution, actually there are used innovative heat exchangers either only the exchanger or combined with heat pumps. You can regain up to 2/3 of the heat, and you can install it from 10 to 100 kilowatt. And it starts actually with available wastewater volume from 3 to 10 cubic meter a day. And there it is the internal use for, of course, also the building itself, but the preheating of the water. So then we have here the sewer energy scheme. You see here very well that we put, in this case, the heat exchanger either in the sewer or next to the sewer. And the sewer provides the thermal power. And there we extract this power and transfer it then to heat pumps, and then further on to the regular heating in the building. And the heating and cooling capacity depends on the targeted temperature with a COP of 4 to 5. So what is, or where can you put in or how much actually, or how are the requirements for the economical operation? So you need at least a flow rate of 10 liters per second on a daily average during dry weather. You need, the temperature should be minimum 10 degrees Celsius, and you need a minimum required duct diameter of bigger than 400 millimeters. And the distance from the sewer channel to the consumer should be maximum 900 meters. And the number of, or the connected consumers, there you need more than 50 kilowatt power. So the technology for the heat exchangers, you see here also, this would be the sewer where the heat exchanger is placed. And then there is also a piping systems underneath this heat exchangers. And then you have here this flowing, the water flows here through the channel and then back to the pump and then to the customer. So in this sector, you see the heat exchangers which are placed into the sewer. Here, here the model, and here you see the pipes. And when it's finished, it looks like this here. So it is suited actually for all channel types, and this system is actually industrial manufactured plate heat exchangers made of stainless steel. It is installed in existing or new built channels, and you need a complete overflow during periods of dry weather. And it is a very quick installation, and you don't have visible pipes, you see it here. And the lifetime is more than 50 years for this stainless steel heat exchangers. Then we have the external heat exchangers. You see here on this model that here is the sewer. You need an extra manhole or pumping station where you put out the sewer from the sewer itself, the water from the sewer itself, and then you bring it into the machine house where the external heat exchangers are positioned, and also the heat pumps, and then you come to the customer. So this technology for the external heat exchangers, those are self-purifying tube bundle heat exchangers in combination with heat pumps for the heat recovery installed outside the sewer duct. And they are resistant heat exchangers, and they are specially designed for wastewater and sludge. And the wastewater abstraction and the external pumping station are required, as I showed you before. So I bring also a few examples on several projects, and here are the projects with channel heat exchangers. There are some projects in Germany where it was designed to deliver 105 kilowatts for heating, 130 kilowatts for cooling. There is another example in Wangen. There it was 400 kilowatt heating, and also into the district heating bigger than 80 degrees. And there was also another project in Rheine where 105 kilowatt was delivered for heating and 130 kilowatt for cooling. And also one project in Stuttgart where 300 kilowatt heating and 484 kilowatt for cooling. And there are also some examples in Austria where for offices and business parks, we did one project for Wien Canal in Blumenthal. The first project, it was done 3 years ago. There were 360 kilowatt heating and 750 kilowatt cooling. And the next project, Blumenthal 2, is under construction at the moment. And there will be at the final, at the final project end, there is a capacity of 430 kilowatt heating and 450 kilowatt cooling. And there is another project in Innsbruck which delivers 150 kilowatt heating. And so you see with all those projects here that actually cooling is, in this you see the special, is a very important part. And for renewable cooling, I think also this will be really the future. You can take out the energy from the sewer and use it for heating. And also in the summer, you can recover it and put it back for the cooling. And so there is a very big example also for the bypass solution. Here, there is an example, the NATO hospital in Budapest. There was also heating and cooling of the whole hospital complex, the requirement. The installation was done in 2014, and up to 3.8 megawatt was produced for heating and 3.2 megawatt for cooling. And you see here also the project specific, it was the tube bundles for the external bypass solution. The heat exchanger was really for this project specific planned. And there are 18 heat exchangers with 200 kilowatt capacity each. And of those 18 heat exchangers, most only 12 are in use. So the maintenance can be done on the other ones. And so there it is guaranteed that the ongoing operation will not be interrupted at all. And there is also a very high self-cleaning effect on the heat exchanger bundles, and this is monitored all the time. And there are also used then in this project high-performance heat pumps, and there are also 2 heat pumps with 1.9 megawatt heating and 1.5 megawatt cooling capacity each. And so the pump 1 is actually for the base load, and the pump 2 for the variable demand coverage. And here in this project, it was possible that it could be reached a COP of 6 to 7. And there are also then examples for using the sewer of treatment plants. There is, for example, a project in Muri in Switzerland. There are 200 flats heated with this system. Then there is the sewage treatment plant Weiz in Austria, where there are things 209, the heating and cooling for commercial buildings. And also there is a lighthouse project in Graz, Gössendorf, where there should be feed into the district heating, and also the requirement for the heating is 7 megawatts and the cooling 3.5 megawatt. And there are also some projects going on in Vienna. There is planned a 200 megawatt input for the district heating system, also with the energy put out of the sewage treatment plant from the sewer. And there's also a treatment plant used in for the heating and the cooling of the treatment plant itself in Budapest, and also for the stabilization of the plant biology. So what is required actually to decide if the heating and cooling with renewable energy of sewer is possible? You need first a potential survey via data collection. So you need to know, is there any public sewer near the building complex? How much wastewater flows through the sewer and at what temperature is it? And what distance is actually from the sewer then to the potential energy consumer? So actually with each project, you should really investigate if renewable energy with sewer is possible for the heating and cooling of the building. So of course we need then the survey of the customer, the energy requirements, the energy concept, and all the availabilities. And of course then there needs to be a pre-coordination with the wastewater company if they are ready to actually make a contract then to supply the wastewater. And of course then there will be done a feasibility study. You need to assess the economic feasibility. You need to select a suitable technology, the financing, and also of course the form of the operation. And of course clarification of the subsidies, as the sewer recovery is also renewable energy. There are in many countries also subsidies provided for this. And of course then there needs to be the project implementation. Before this you need a basic detailed engineering, the construction and commissioning of course, and then there needs to be a private law agreement with the wastewater company. So we as Rabmer Group, we are actually active in this technology since a very long time now. And we are of course also ready, if there is some interest also in Ireland, to provide some information. We can, whenever you are interested in using renewable energy from wastewater for heating and cooling of buildings, we provide a checklist where we have the first questions. And of course, whenever you are interested, we are ready to support you with this.
Thank you very much, Ulrike. Very interesting insights. Ireland set a plan to cut CO2 emissions by 50% until 2030. So I think there will be a lot of Irish companies and institutions are currently looking into different areas on how to save energy on all over the island. So I guess there will be some interest in your solutions here. Thank you very much.
Thank you very much. Thank you.
So this is the end of the first part of today's conference. We will shortly kick off the digital one-on-one meetings with a unique opportunity to talk with your exhibitors. Please take a second to log into your account to check if you received any meeting requests. I did it before myself. I saw that I had 2 meetings on hold, and I just accepted the meetings. So please go ahead, check into your account, get a coffee or a tea, and sit down to chat with our exhibitors. These are known companies. They have, I think, some very good solutions, and some of them are really looking for partners here in Ireland. And yeah, and that's so far from my side. Thanks for being with us today. And I try myself now on Irish. I wanted to say slán, goodbye, und auf Wiedersehen. Have a good day, and looking forward to welcoming you to one of our next events in the area of sustainable building and to creative solutions, furthering and working together Ireland and Austria. Have a good day. Bye.